All right, we are back with chapter 19. We talked about neurofeedback last week, and we're going to continue using a lot of Van der Kolk's book. So first, the history is Hans Berger recorded the brain's first electrical activity in actually 1924. Of course, this was met with a great ridicule. He discovered different brainwave patterns reflected different mental activities, like math problems resulted in beta bursts. So he was way ahead of his time, and he is recognized as being the first one who utilized this. Most hyperactive and impulsive children had slower than normal brain waves in their frontal lobe. So when we look at this and we look at the history, you could already see that in the history. And then Bessel talks about it a lot in the chapter. And now we know this serves as a biomarker for ADHD. That slow frontal wave or delta wave activity explains why these kids have poor executive functioning. And the rational can't really work. The prefrontal can't really work because it's not activated in the right way. And that way it can't control the emotion. This also happens in trauma and abuse, and why ADHD and trauma and abuse are often misdiagnosed. ADHD is given for a lot of times for learning disabilities, and learning disabilities and ADHD are misdiagnosed a lot. And often can be a traumatized brain. When you see in that chapter with the case of Laura, you can see that it's obvious that she could not function because of her trauma and the impact that had on her brainwave activity and her brain connectivity. And so at the end, she was homeless and in group homes and cutting herself. And by the end of the chapter, you see that she's a nurse. And I mean, I love those stories. I think it's amazing. So one of the studies they talk about in the neurofeedback chapter is this study out of Australia where they looked at traumatized brains versus quote unquote normal people. And they used this oddball paradigm test. And some of you may remember that if you were an undergrad psychology major, that oddball test is where you kind of look at a series of things like a row of chairs, and there's a zebra in there. So something doesn't fit in the series of images. It's out of place. It's like if I'm sitting in my study recording this, if there was a stove in here in my study, okay? But none of those images were trauma related. They were just chairs or whatever. There was nothing in the images that would be traumatic. Sometimes if you remember, back in chapter 6, I think, when we had those images, they were just regular images of people doing things. It wasn't even like that, because remember people, I think there was the guy fixing the car, and they're like, oh, he's about to drop the car, the kid's about to kill the dad or whatever and smash, and there's blood everywhere, right? So this is even more of a less triggering study. And what they found in that Australian study with the traumatized versus the non-traumatized group, in the normal group, the key parts of the brain worked together and produced this coherent pattern of filtering, focus, and analysis on the left. And you see the convergence in the P300 wave dipping down here on this left image. And this is the one that is like the normal healthy brain. Okay. And then this one is the traumatized brain. So in contrast, the brainwaves of the traumatized subjects are loosely coordinated. So really what you want is what we call like cohesion, and you want them compressed and converged. And when they're not, you know that there's some issues and they're not coherent. Specifically, it did not generate brainwave patterns to help the person pay attention in the oddball paradigm by filtering out irrelevant information. The depth of the wave here was very poorly defined in the focusing task. So think about people who cannot filter out irrelevant information, ADHD, etc. It's very, and I think about when you're trying to make a decision or function, go to school, and you can't filter out what's relevant and what's irrelevant. And when you say that, when you look at that and you see it in the brain, it really makes a lot of sense as to what is happening with a lot of individuals. By the way, I upgraded my Screencast-O-Matic. It works so beautifully to put the link in, and I'm going to do that from now on. I don't want to cause you guys any headaches with trying to watch this, but I don't have my camera on because I'm not I mean, I could have it on, but like, I'm not 100% ready. I work from home today. So anyway, I hope you just enjoy listening to me and watching the slides today. So this study tells us how traumatized people can process non-traumatic information. This also explains why so many people could have trouble learning from experience and fully engaging in day-to-day life. If you think about veterans and you think about people with PTSD. So brains are not organized to pay careful attention to what is going on in the present moment when you have the traumatized brain based on this oddball paradigm study. So that's really difficult to function when you can't do that. Oh, I was going to talk about The Hurt Locker. Let me pause this. So I don't know if anyone's seen the movie The Hurt Locker. So I love this quote on the top of page 314. It says, Sandy McFarlane's study reminded me of what Pierre Genet had said back in 1889. Traumatic stress is an illness of not being able to be fully alive in the present. The movie The Hurt Locker, which dealt with the experiences of soldiers in Iraq, which I highly recommend, it won an Oscar years ago. Bessel thought of Sandy's study. And as long as these guys were coping with extreme stress, they would go up and diffuse bombs is what they did. I mean, think about how stressful that is. And they performed pinpoint focus and were excellent at their jobs. But when they got back in civilian life, they were overwhelmed having to make simple choices in say, such as supermarket. Vanderkart talks about now we see alarming statistics about the number of returning combat veterans who enroll in college on the GI Bill but don't complete degrees. They have trouble focusing, and attention are the things that are making them struggle. So when you think about that, and you think about and Mark McFarlane's study is this one, and so when they reference that, it's a possible mechanism for the lack of focus and attention in PTSD. These dysfunctional brain images that we have here. And then you can kind of see in the book on page 315, you can see where Seaburn Fisher is the premier researcher, written premier textbooks on neurofeedback, and in the neurofeedback world is famous. And you see Seaburn talking about working with this 10-year-old here, and you see the pictures, drawing after 20 sessions, drawing after 40, in the first drawings, and you see how those drawings change after 4 months of neurofeedback is equivalent of 6 years of development. So it's really, really interesting. I think this chapter, and even for me, was a great review of neurofeedback. I'm trained in it. I have everything for my certification, and like I said, it's very complex. And rereading this chapter for this class helped me learn more. It's really interesting. I called my colleague and said, gosh, just reading this again brought more to light for me because it is very, very, very complex. There's this great chapter here in Symphony of the Brain, and thank you, PowerPoint, giving this beautiful little slide. I didn't want you to miss that. I already got ahead of myself again. Seaburn is a leader in the field of neurofeedback. Neurofeedback, what it does is gives us a mirror of brain function. We're able to look at that. And like I said in my last lecture, which was my own lecture, just something I've done for a conference before that I wanted to bring in. And this is more along the lines of following the text. And what we do is then set the reward and inhibit the frequency. And I talked about that in the last lecture. So you actually calibrate those protocols, and you're rewarding the brain when it's in the frequency you want it to be. And then it's not rewarded, it's not punished, it's just not rewarded when it's not in the correct frequency, and it learns. And when Bessel was learning about it, they moved the electrodes around the brain and can see how that can impact functioning depending on where your brain training. And I think you can also see how powerful it is for operant conditioning. You see in the text, and you hear me talk about, how traumatic and triggering it can be. We had someone that one of my colleagues were practicing on, and even myself, and they had all these different electrodes on, and they didn't know what they were doing. And I did not, it's not actually putting anything in my brain. And It messed me up so bad. I had to go home and lay down for 3 hours, and it's powerful, and it's met with many cautions when you get trained. We can't, neurological issues, trauma. When we train T3, T4, we have to be on guard, and it's really better if you go ahead and work through all the trauma and the history, and then pull that part up in T3, T4, because you can activate trauma. And again, they're doing operant conditioning, so it's really interesting. So, how would neurofeedback treat trauma? So, what it does is it intervenes on the circuitry that promotes and sustains fear, like traits of fearfulness, shame, and rage. It's the repetitive firing of these circuits that defines trauma. The patients must change the habitual brain patterns created by the trauma. So that we know and can see trauma in the brain. And we see that in the sensory motor rhythm, in the default mode network. And when you get that report, like I showed you in the last class, when you get that report, it'll say sense of self, and that's trauma. It's a nice way of saying they have a dysregulated sense of self. And what that is they're not a cohesive self, and they have division in their brain. And so they can't access all those areas in their brain in order to feel like a person who has their whole self together. So when those fear patterns relax over time, and you do the brain training, that brain becomes less susceptible to automatic stress and better able to focus on regular life and stay in that window of stress tolerance. It increases resiliency and helps clients feel like they have more power and choices. And we do see that as happening. We got into the history a little bit in here, and I wanted to make sure, you always want to, and I always bring history up with clients. But the research in neurofeedback was strong. There was an article in Psychology Today in 1968, discussing how alpha theta could relieve stress in stress-related conditions. But then in the 70s, right, we got more psychotropics, and then they got all the love. And neurofeedback got less money and research and attention. So always know that history. It informs you because it's coming back around. And it works. It works. And we're all going to be doing some form of this in the future. That's my opinion. I can't speak for everyone. That's my opinion. Other old studies that were really interesting that the text laid out for you, that National Aeronautics study that was studying the toxicity of rocket fuel, or MMH. And MMH, what MMH does is it causes hallucinations, nausea, and seizures. And of course they want to study that because we don't want astronauts and others who are exposed to rocket fuel to have the symptomology when they're in space, right? And so Sturman is a researcher from UCLA, and he had trained cats to produce a specific EEG frequency known as SMR, or somatosensory motor rhythm. Or sensory motor rhythm, same thing. So the ordinary lab cats had seizures when they were exposed to rocket fuel, but the ones they had stabilized, the little kitty cats with the EEG, they did not. So it's really, really interesting and powerful research. Now, what is the sensory motor cortex? I went to my neurofeedback text to pull some more information for everyone. It didn't really tell you what that is, and I'd like you to know what we're talking about. So the sensory and motor cortex runs parallel to one another, and they're divided by the central sulcus, often called the sensory motor cortex. The key functions of the sensory motor cortex, and you'll see that I put C3, C4, CZ on that 10-20 map. Do you remember when I taught you and I showed you the map and the EEG and the corresponding sites? That is the 10-20 map. So that's the international 10-20 where, EEG map, and those regions in the brain, C3, C4, CZ, are in the midline in the central sulcus. And so those are where you would train the sensory motor cortex. So what does the sensory motor cortex do? So it has spatial discrimination and the ability to identify where bodily sensations originate. So if you think about that in SMR, that's what we do SMR. Usually every client we do SMR with when they first come in. But think about complex trauma and complex regional pain syndromes, etc. That therein lies the issue, right? If you cannot understand where pain originates, and you cannot feel and can't discriminate with space and feeling, then it could be problematic. In the SMR cortex, it marks the division between the parietal lobes and the frontal lobes. It really divides the anterior brain from the posterior brain. I have a little trick to remember anterior, dorsal, posterior, and ventral. I made up a little sentence. It's so funny. It doesn't make any sense. It's Addie did pout viciously. And I start with my nose and go around at each point, the nose, the top of the head, and the back, and under my chin. And that's how I remembered it. So I don't know if that helps you guys. It really is helpful to know anterior, posterior, etc., because as clinicians, it comes up quite a bit. And the Greek word for soma is body. That was just something to help you remember. This SMR is responsible for external sense of touch, temperature, pain, internal sense of even joint position, and visceral pain. So when you have complex PTSD, complex pain clients, which often are 99% of the time hand in hand, when you train SMR, you may have some relief. So training along SMR cortex, and I gave you a nice graphic so you could see where this actually is. And if you did Addie did pout viciously. Maybe everyone will be going around saying that at some point. When I was taking my, I think, biopsych or something, I had to come up with some acronyms to remember things because I couldn't remember it. So training along this cortex here, it has implications for stroke, epilepsy, paralysis, ADHD, and then disorders of sensory integration, that sense of self, sensory integration, DID, the kind of stuff we've been talking about. So I love that this is at the end of the kind of the work that we've done so that it's a nice kind of cap to everything that we've learned. Here's Sturman again. He also trained Margaret Fairbanks along with the SMR region. She was the first epilepsy sufferer to receive EEG neurofeedback training, and she was the first human success story. Shares in orchestrating both physical and mental processes. If a client has trouble with logical ordering and sequencing, we can train in this area. Depressed clients respond really well to C3 and C4 only because they're near the insular cortex, Brodmann's area 13. And we can train children in C4 for dysregulation. This is kind of along that SMR region that I just mentioned. That's where those electrodes would be placed for the brain training. One other thing that's kind of interesting is SMR sleep spindling can be seen when we're sleeping. SMR is movement, right? So these sleep spindles are on the EEG, and they are a hallmark of what we call non-rapid eye movement, or not in REM sleep. And they're believed to mediate many sleep-related functions, from memory consolidation to cortical development. So this is all really, really interesting. This great case about Lisa here. She came in group homes, mental hospitals. She was a regular at the ER for overdoses and self-injurious behavior. Her mother was very psychotic and very abusive. It was really horrific to listen to. She was stuck in inescapable shock. She couldn't even recognize herself in the mirror. In half a year, the voices stopped. And then ultimately at the end of the chapter, you see that Lisa became a nurse. So you can't make this stuff up. It's all based on research. And that's why I like the Body Keeps the Score, because everything's based on research and actual studies that have been conducted. So our brainwaves, we talked about this in the last class, but Bessel talks about it again. And perhaps by the time you finish this class, you will have a really good grasp of what neurofeedback is. I say that because I went to several trainings and was still lost after I left. And my goal is to always make sure that things are easy to learn and not so mysterious for everyone. So the rate of brainwave firing is related to our state of arousal. Those delta waves are the slowest frequency. There's a typo in this. I did just do this PowerPoint for y'all. So this is a new PowerPoint. I'm going to work on it some more, but it'll be a work in progress. But the slowest frequency hertz is 2 to 5 hertz or delta. Are seen most often during sleep, and the brain is kind of idling and turned inward. If we have too much delta wavelength while awake, then we're foggy and we have poor judgment and poor impulse control. Actually, 80% of children with ADHD and many people with PTSD have excessive slow wave activity in the frontal lobe, like we mentioned in slide 1 and 2. Those theta frequencies, they predominate that edge of sleep, that really nice drowsy little feeling, that hypnopompic state. EMDR is also characteristic of hypnopompic states. And we're very malleable in that state, and a lot of healing can occur. Bessel talks more about alpha theta training for PTSD and alcoholism. Alpha theta seems to loosen those frozen associations and faulty learning and gives us new learning. That's really important when you are stuck in repetitive negative beliefs and trauma. That would free you up. So, if you will. And I told everyone about my cool alpha theta experience. Again, just with listening to birds and waterfalls and having those electrodes measure and reward me is really am a believer after having that experience. Alpha waves are accompanied by a sense of peace. So alpha, other than theta, their hertz are different. Like delta was lower, beta is higher, alpha is this. 8 to 12 hertz is where they operate. And that's how you can tell the difference in the wavelengths. This is what happens. This is what happens in alpha theta and what happens in mindfulness meditation. We get in this alpha wavelength. So 20 sessions of neurofeedback can also create what we call the Peniston effect. With substance abuse and alcoholism, if you alpha theta train, and it's a little bit more than that, but every day, you can actually make people allergic to alcohol. And that's in your book, and that's been proven. I don't know why we don't do it more, but it is a really interesting thing to think about, and we have been trying something similar at the practice. Beta waves are the fastest. They're 12 to 20 hertz. When beta is dominant, the brain is oriented like to the outside world. We can engage, we can interact. High beta is over 20 hertz. And when we have lots of high beta, that means we're angry and anxious and our body's tense, like we're waiting for trauma. So that polyvagal theory, if you think about it over and over and over, you might have really high beta because you're constantly scanning the world for danger, and it's productive to be in that fight mode. So we have to retrain your brain to know, hey, you don't have to be in high beta over 20 hertz. We can reduce that down. Neurofeedback can also be used to help train the brain for optimum functioning for peak performance with athletes. In fact, in the Italian World Cup in, I think, 2006, they used neurofeedback to train athletes and then won the World Cup. Also, Canadians dominated the Olympics because they also trained their athletes over a 5-year plan with neurofeedback and dominated because of it. Musicians can benefit as well. There's a 10% improvement after neurofeedback in almost all musicians. Neurofeedback is also the most effective treatment for ADHD. At least 36 and far more now studies have shown that neurofeedback is as effective as a stimulant prescription, if not more, without any adverse side effects. So also, your text talks about now there's software that's color coded. So I showed you that. You saw that in the last lecture. Remember the NeMind software. So where's the problem in my brain? We can see it. We look at it and it's correlated with those databases. And then we can give you an idea of what's going on and then a graphical representation of it. It's really neat. So how does trauma change the brain? We see in this text, and we see at my practice how traumatized brains look totally different. Like for this example, there's excessive right brain wavelength, temporal brain activity. And think about that. That's where the fear-based memories are. That's the fear-based center of the brain. And that's combined with too much slow wave in the frontal lobe, delta, and not able to focus or function. That is the medial prefrontal cortex and the limbic. We need those to be working correctly to be healthy. This means hyperarousal can control your mental life. Calming that fear center decreases trauma and increases your ability to use those executive functioning processes in your medial prefrontal cortex. There is a great study that Bessel talks about in changes in the brain after deployment. The QEEG measured 179 combat troops. They used that measure. I taught you about that last time. For 4 months prior and 4 months after each successive deployment to the Middle East. Findings suggest that the total number of months in combat over a 3-year period decreased alpha power at the back of the brain. And what that area does is regulate sleep and hunger. It monitors the whole state of the body, we're showing persistent state of aggression. And then beta waves at the front of the brain were growing progressively slower, akin to ADHD. So if your soldiers are coming back and they're not able to focus on day-to-day tasks. Neurofeedback and learning disabilities, I already discussed that. Lisa could not learn because her brain was so traumatized. How many learning disabilities are really actually trauma? Sorry, if y'all hear my children in the background. Oh, thank God. I was like, am I going to get through this? Hopefully this was not too much information. Read 19, review 18. I'm going to put this in your module, and I look forward to hearing from you about what you've thought over the past 2 weeks about neurofeedback. It can be overwhelming to learn, but anyway, I hope y'all enjoyed it.